math used in violin. The violin, a finely crafted string instrument, relies on mathematical principles for its structure, sound quality, and tuning. From the curvature of the body to the placement of the strings, mathematics ensures precision and harmony. Let's explore the role of math in the violin. Violin uses math in string vibrations and frequency. The frequency of a vibrating string follows the equation Fe 1/2 L T M, where L is string length, T is tension, and M is mass per unit length. Adjusting any of these factors alters the violin's pitch. Fretless precision and ratios. Violinists rely on mathematical ratios of string length to create different notes. A perfect fifth tuning system ensures that the strings follow a 2.3 frequency ratio. Curvature and acoustics. The violin's body follows an intricate geometric design, often based on Fibonacci sequences and the golden ratio, 3=1.618, optimizing resonance and sound projection. Bow speed and pressure. The force applied to the bow affects sound intensity, following Hooke's law, F=kx, which describes the elasticity of the bow's horsehair. Mathematical principles applied. Wave equations describe how strings vibrate to produce sound. Golden ratio governs the violin's elegant shape for optimal acoustics. Frequency ratios ensure perfect tuning and harmony. From the design to the performance, mathematics makes the violin a perfectly tuned instrument capable of producing beautiful melodies.